what it should equal, then what can you say x squared plus x minus 2 is equal to? X minus 1 times x plus 2. So this is, again, this is like when I said 15 divided by, did I use 5 or 3? 15, what did I use the first one? 15 divided by 5 I said was 3, and that meant that 15 was equal to 3 times 5. Same sort of thing. If this divided by this is this, then the top should be equal to this one times that one, right? And in some kind of weird way, haven't I actually rewritten this factored? Yes? Like I have factored it without actually using any technique. I mean, you used the technique to get to the x minus 1, but just trying to get you to see, if you have a polynomial and you divide it by a polynomial and you get a nice answer, then we can rewrite it this way. And then it is, in essence, it is factored. Right? Again, we're kind of leading into this. So how do we do that division and get x minus 1 if we didn't know how to factor that?
Put the top underneath the division sign and divide it by whatever's on the bottom.
Wait, say again?
Division.
Long division. That's right. So we cheated here. Was it Lilius? Lily. Okay. What does your name tag say? See, I'm confused. All right, Lilius. Lily. All right, Lily gave us the hint that we should factor just to figure out what the answer was. But the whole idea here is, what if you can't factor that, right? So let's act like we had no freaking idea, all right? No idea that that factored that way. How could I get the answer of x minus 1 without that factoring? What we use is what's called long division. Show of hands, long division. How many of you have ever seen long division before? I did. I showed it to you?
Yeah.
Oh, I did?
Yeah. And it was really confusing. So.
Okay. In my Cal 2 class yesterday, we were doing a problem. These problems were taking us about 45 minutes to do. And the very first step of the problem was long division. Fortunately, they all knew how to do long division, so it made me feel good. But in this class, I assume that you are not that familiar with it, so I'm going to kind of expose you to it almost like a first-time thing. All right, so let's try something. I'm going to, again, go with an analogy below to kind of help guide us here. If I said take 15 and divide it by 4, and like you said, that wasn't a number you knew how to do, right? Then what you would do back in grade school is you would do this division box. You'd put 15 here, and then you'd put 4 here, wouldn't you? Yes. And then you'd say to yourself, what do I multiply 4 by to get 15? But I can't go past 15, right? So you say 3 is the biggest number I can get, right? 3. And then what did you do? You took the 3 and multiplied times 4 and got what? 12. And where did you put that 12? Under the 15. And then very important step right here. What did you do? Subtracted that number, right? And then you got what? 3? Yes? And then you go again. Does 4 go into 3? No. And then you brought your decimal down. You did all this stuff. But that was the basic idea, right? Basically, the structure of it. And also, there was even a point in time where we said R3. That was like way back in the day, right? Remainder 3. Before decimals. Right? All right, we're going to do the same exact process on this. So what should go inside the box? X squared plus x minus 2. And this must be in descending order. Must be highest power of x down. If you write this in any other order, it's going to mess you up. What should go on the outside of the box? X plus 2. And that should also be in descending order. Highest power of x down. Now here, it was easy because you said, all right, what do I multiply 4 by to get 15? Are you seriously going to say, what do I multiply x by 2 by to get all this crap? It's going to be too hard. So what you do is all you focus on is the first term, the very first term. X and the very first term over here, x squared. You say, what do I multiply x by to get x squared? X, just an x, right? And then what we'll do is we'll put the x up here like we did with the 3. And some people are real anal about this. They like to line things up. Like, notice that this is like x squareds, and then this is x's, and this is numbers. They say, OK, I'm going to multiply by x, so I'm going to put it right here so it's lined up. I don't care. Just put it up there somewhere. All right? But I'm just letting you know, some people are real particular about that. All right, so when we had the 3, right, what did we do with the 3 next step? 3 times 4, and then 12? 3 times 4, 12? Well, we actually have to take the x and multiply it by what? X plus 2, the whole thing. The x has to multiply times the x plus 2. So you're actually doing this. X, this is going to be on the side over here. X times x plus 2. And then you distribute, and you get x squared plus 2x. And what I do is I put those underneath here, and I make sure I line everything up. I have x squared, right? So x times x was x squared. X times 2 was 2x, and I put it there. Then I come through and subtract. And when you subtract, doesn't it change the signs of what's here? So this negative x squared, this becomes negative x squared, and this becomes what? Minus 2x. So I make a real big exaggerated negative sign so you know that I changed it. And now you add down, which you actually added down here. You did 15, you added to it negative 12, and that gave you positive 3. So what do we get when we do this? Negative x minus 2. And so we've done the first sort of iteration of long division. Okay, we've done the first cycle. Now we're going to repeat the process. We're going to look at the same x out here, and now we're looking at what's here. And we only look at the first one, which is negative x. Can you multiply x by something to get negative x? Negative 1. Right? And now you don't look at the x anymore because we already did the x through there, right? You look at the negative 1. You pass the negative 1 through these. So negative 1 through the x plus 2. And what would you get? Negative x, right? Negative 2. Change the signs. Add down. Everything's gone. You get a remainder of nothing, right? Which means you're done. And this is our answer. And that means this was x minus 1. Got it? I have to scroll through this. Let's take a look at what's that? B is
A factor is fine.
B is not. B does not factor. Okay, so. Oh, Nathan, I'm so glad you asked that question. Nathan is asking, how do I determine what to divide it by, right?
Yeah, for like the very first one.
Yeah, because what this method shows is that if something can be broken down, right, and you divide it by the right thing, that other piece that's missing you'll be able to get. But how do you figure out what to divide it by? That's called the rational zero test, and we're not going to get to that today. But we will have a way. And you won't like it. Initially, you won't like it. But I think you'll come to appreciate it at some point, hopefully. You won't like it because what it's going to turn out to be is it's going to be a list of maybe like 20 or 30 things that could potentially work. That could potentially work.
Can we write those down for the test?
You'll be able to create the list yourself. And then you have to try them until they work. Yeah, I know. Okay, so let's now look at this.
I was wondering why you were saying it's going to take 45 minutes to solve the problem.
Right. We'll have a quick way of doing it. It'll be pretty efficient and fast. Because after we do a little more long division, we're going to learn something called synthetic division, which is a quicker way of doing division. But it only works in certain scenarios, so we have to be careful with it. All right, so same thing here. Let's do long division. Long division. So here's my division box. X squared plus 2x minus 15. What goes on the outside? X plus 5. All right. What do I multiply by first? What's x up here. X times your x is x squared. Do you want me to let y'all do this? I mean, yeah, you want to try it? Okay, you go ahead and do it. I'll do the work up here. Then you can come back and check. I've fallen a little behind on the grading of the quizzes. I will try and get caught up on that. I apologize. I planned on doing it this morning, but then I know, but I still just haven't even opened up the folder, to do it. So, yeah, exactly. Hey, easy now, easy. You got your grades. You got your test back the next class, and you knew your grade within 24 hours. It's all right. It'll all work out. All right, everyone get x minus 3?
Yes.
If you did that one, do the next one, see what happens. Do B.
That's what we just did with B.
No, that was A. A had x plus 5 down here. B has x plus 4 down there. Anybody still working on A that has a question that ran into any issues? I will pass the attendance thing out today, though. So just initial and column for the 30th there.
When you got to this, did you do that by the sum of the difference of two cubes?
Mm-mm.
Or how were you just, where are we going over that?
That's what. I know you're eager to know, but you got to wait for it. It's going to take a little while. Once you have the method, then you'll be able to factor a lot of things. Anybody still working on A? Definitely?
Yeah.
No?
Yeah.
Yes, you're on A?
Yeah.
Well, why didn't you say? You need help? Okay, so that's fine, good. Now you say, what do you multiply x by to get negative 3x?
Well, 3.
Negative
Okay.
3,
I was
right?
just stuck on that, yeah.
Okay. Gina got it?
Yeah.
Yes? Okay. You're good?
Yeah.
Okay. You're running into a problem on it when it's x plus 4, right? Get a little bit of an issue here. So the answer to the first one should be x minus 3. All right, I'm going to walk through the second one because this one's a little bit weird. You put an x up here, you should get x squared plus 4x. You subtract, you get what, negative 2x minus 15? Then to turn x into negative 2x, you multiply by negative 2. What's that?
You made the 4x positive. It's equal to negative.
It was positive. I made it negative. And then plus 2x minus 4x is negative 2x. It looks positive. There. That's my minus sign. So negative 2 times that, negative 2x, and then negative 2 times that gives me, what, negative 8? And then you change the signs. And then this, and remainder of negative 7. And so this has always been 0. And we were able to say, okay, great. That's like 15 divided by 5 is 3. There's nothing left over, right? But when you did 5 divided by 4, you had something left over. Yes?
Plus negative 7 over x.
Yeah, so how do we write this? That's what we need to make sure we understand. This, we do not write our negative 7. Okay, we don't do that. What we do is this. We put plus, always plus, the remainder, negative 7, over the divisor, x plus 4. So this is the answer. But we have not factored it in a nice way, right? What this tells us is that x plus 5, or sorry, x plus 4. It tells us that if we try and break this original problem out to be x plus 4 times something, that something here is not nice, right? This is ugly because that thing is now a fraction. It has x in the bottom. It's a mess. What we want are nice things like x plus 4 times x plus 2 or something like that. So that means that even though we can still do long division and get an answer, that would not help us in factoring this. Understand? So remainder of 0 is what we're keying in on. If we can find remainders of 0, we're in business. Let's look at C. C is a little bit different.
So is that the answer?
The answer to this long division would be this. But in terms of factoring and helping us factor, it doesn't help us factor. So remember,
Something like that, what's the next?
do you remember you asked me where the bottom would come from, and I said we would create this list of possibilities. When that happens, it didn't work. You go to the next one. Exactly. So you're going to fail more times than you succeed with that technique once we get to it. All right, so let's look at C. X cubed minus 8 over x minus 2. And I'm sure there are people in this class that already look at that and know that the top does factor because it's a difference of cubes, right? But that's not what I'm asking for you to do here. I'm asking for you to try and do the long division. Now there's something different about this problem that you need to pay attention to. What's supposed to go inside this division box? X cubed minus 8, right? But because we do not have an x squared term, right? There's not an x squared here, and there's not an x here. In the long division box, we still need to account for them because what we need are vertical columns. In case when we do our multiplication we get x squareds or x's, we need a place to put them. So some people do just leave space and then put minus 8 back here. Other people will actually put plus 0x squared plus 0x. And these are just placeholders. Do you all understand that? If you forget those and you try and cram it all together, it will become a disaster. I'll show you over here, while we do that problem, I'll show you over here someone who forgets to do that and the problem they're going to run into. All right? So what goes on the outside? X minus 2. Okay, x minus 2. All right, so we look at this and we focus on the first x here, and we need to turn it into x cubed, right? So we multiply by x squared. Just put that here. And then you actually distribute the x squared through to each of these. So x squared times x gives me x cubed. And then x squared times negative 2 is what? Negative 2x squared, right? So I'm going to put that right here, negative 2x squared. Do you all see how that would cause a problem over here? If you put an x squared up here, and you multiply first one x cubed, where are you going to put negative 2x squared? You can't put it under the 8. They're not like terms. You can't add them together. So where are you going to throw it? On the outside over here somewhere? I mean, you're going to run into some issues with space. Understand?
Yes.
So always look for those gaps and then account for them. Come through, change the signs. Add down. What do we have? 2x squared, nothing, right? And negative 8. What do you multiply x by to get 2x squared? 2x. And now do your distribution 2x to here, put those answers underneath. So what would you get underneath there? 2x squared, and then minus 4x. And notice I line that up in the x column. I don't try and put it underneath the negative 8, right? Come through, change signs, add down. So the 2x squared, these cancel, we get 4x minus 8. And then you play the game again, right? You go, okay, here to here, I need to multiply by positive 4. And then you multiply, and it works out perfect, doesn't it? Change the signs, you get 0. So that means it does actually break down to be this. So the answer is x squared plus 2x plus 4. Agreed? That's your answer?
Is that the answer, or is it x minus 2?
No, this is the answer for this. The way the problem appears up there, this is the answer right here.
Okay.
But for where we're headed, we want to all understand that what this really means to us down the road is that x minus 8, or x cubed minus 8, can actually be rewritten as x minus 2 times x squared plus 2x plus 4. So that's the answer for this problem, but this is where we're headed with it. So you essentially have factored this. Now what's kind of cool about this problem, can I erase this or still need it? You good? Okay. What's kind of neat about this problem is that there was a formula, x cubed minus y cubed, difference of cubes formula that looks like this. That's the difference of cubes formula. And for us in this problem, isn't y 2? Isn't 8 2 cubed? So if I replace all the y's right here with 2, wouldn't I get x minus 2, x squared plus x times 2, which is 2x, and then plus 2 squared, which would be 4? And that's exactly what this is, right? So we would have known this. This confirms the formula. You know, it matches up. But we did it with long division. All right. Why don't you try, let's see if you all can finish the next 3. Well, we have enough time to talk about synthetic division, though. Let's do E. Yeah, let's just do E together. You do E. You do E. Work it out. Work out E up there. And I'll work out E up here. And then E as in echo. Epsilon. Echo? Did the sign-in sheet get around to everybody? Everyone got it? Does it feel like about half of you are here from the beginning of the semester? It's a little over half. If you get an answer, raise your hand if you've got the answer. I'm just looking to see if you put the 0, that's all. I forgot the 0, okay.
Yeah, I forgot.
Got it, okay. Got it. So there was a remainder on that one? Okay.
I did it twice.
You got the 0. Did you put the 0 in there? No?
Forgot it twice.
Twice? So you realized you forgot it and then wrote it down again and forgot it? Did you all get 0? Still confusing you? Okay, good. So can you turn x squared into this? Not easily, so that's it, that's your
Oh,
remainder.
okay.
Yep.
Do you have to bring down that one, do you have to bring it down?
Yes, it'll be negative x squared. Oh, wait a minute, hold on. Yeah, that goes there. There you go. So you don't need to bring that down, no.
No, okay.
I'm going to put the answer up here, work it out real quick. That should be your first multiplication through.
That's where I got it.
And now you have to stop. And the reason you have to stop is because you cannot turn x squared into 3x because this one is a lower power than this.
You put the 3x minus 1.
This is your remainder.
So you put that over the x squared.
3x minus 1, and you put it over the divisor x squared plus 1. Is that what you had?
Actually, you got that.
You got that? Okay. Everyone got this? Okay. So keep in mind with the long division that if the power of the x out here is greater than the power of x down here, you're done. Can't go any further. If they're the same power, you can, like if this were 3x squared, then you could multiply this one by 3. But it wasn't. What was your question, Nathan?
Will you ever have like 3 things on the left, like x squared plus?
Yes,
x
you could.
plus-
Yeah, look, well, none of them are up here, but you could, yes.
And then would you always still just focus on the first?
Yes, you always focus on the first ones. Yep. Okay. All right, so with all of this in mind, there is another type of division that is called synthetic division. When you hear the word synthetic, what do you think? Fake? Right? It's like fake division. It's not real division, it's just pretend. No, I'm not quite sure where it gets its name from, but it's not fake. It's just a shortcut. All right? But here's the kicker for synthetic division. It's a shorter method, it's fast, it's very, very efficient, but you can only do it when you have a linear expression in the denominator, when you're dividing by something that is linear. Let me show you what I mean by that. I think I have a bunch of examples here. Those are the same examples, okay? Can I use, even though I haven't shown you what it is, can I use synthetic division on A? Is the denominator a linear expression?
Yes.
How about on B?
Yes.
C?
Yes.
D?
Yes.
E?
No.
No? No. So you could use synthetic division on the first couple, but you couldn't use them on the last two, which is where synthetic division becomes kind of like not as good as long division. But it turns out that for what we're doing, which remember the ultimate game was trying to factor, you only ever divide by a linear expression. So you can always use synthetic division for what we're going to be doing. But the actual technique of long division is something that you should know going ahead into more math. All right? Okay. Let's do number A. Let's do number A. Let's do letter A with long division with synthetic division instead. So synthetic division looks completely different than long division. It looks totally alien compared to this. And the best way to explain it is to just do an example, show you, and then you're just going to have to pick up on it. All right, we start synthetic division with an upside down division box. All right, y'all seen this?
Yes.
Okay? No? Seriously, how many of you have not seen this? Really? Okay, good. Then, what did we put in the long division box? When we were doing long division, which of these did we put? The top one, right? But with synthetic division, all you do is put the coefficients. Coefficients are the numbers. So there's a 1 here, right? And then a 2, and then a negative 15. So you're going to write here 1, 2, and negative 15. And notice that I left enough room underneath each number inside the box to write something below it, right? Now, on the outside of the division box, in long division, we put this thing, right? In synthetic division, you put what? The opposite of the number you see right here. So instead of 5, you put negative 5. Now, I'm not here to explain why this works or, try and convince you. It's just, this is a method. Just take it on faith that this is going to work out, all right? I hate to tell people that, take it on faith, but this is a shortcut method, so don't worry about how it works. I hate saying that, but all right. I guess I can swallow that pill a little better because long division, we see how it works and we're happy. All right, so synthetic division now works as follows. Everything is set up and we're ready to do the division. So what we do is we always start with the first number in here and we just drop it straight down, which is just going to be 1 here, right? So I've taken that 1 and I've dropped it down. Then what I do is I take the negative 5 here and I multiply it times this 1, which is negative 5. And I bring that back up and I put it underneath this 2. So it's like this and then back up like this. And this is multiplication happening here. Then, just like we did in the first one, aren't we supposed to go down with this column? It's addition, though. We're adding down. Add down. What's negative 2 plus negative 5? Sorry, what's 2 plus negative 5? Negative 3? It's 2 minus 5, negative 3. So I put that here. And then I repeat the process. Negative 5 times negative 3 is, so negative 5 times negative 3 is positive 15, and that goes underneath here, right? And then you add down again, and you get what? 0. The last number you get is always your remainder, and we put it in a little box like this on the side. And don't we like remainders of 0? Yes? Okay, so go back in your notes and look. What was the answer we got when we did this? It was x minus 3, right? Anybody see the answer over here? It comes from these two numbers, right? The first number is the coefficient on x. The next number is the number by itself, 3. So we're going to be able to interpret these two numbers as our answer. Understand? X minus 3. Now, I want you to try and do B with synthetic division. Because we said we could do B with synthetic division, right? What number goes on the outside of the synthetic division box?
The opposite.
The opposite. So it was it'll be negative 4 on the outside? Okay. You should get a remainder of negative 7 when you're done with your synthetic division. And then you still have to interpret the answer, right? This is x minus 2 plus the negative 7 over what? X plus 4. Is this all right? Try C. Be careful with C. What am I hinting at? Be careful with C. You have to take account for the x squared and the x, and if they're not there, you have to put zeros in there. That's the proper setup for C. Joe, get it? Yeah.
I want you to show me how.
Okay, 1 came
I
down,
got all the numbers, so it's the
2,
1, 2, 4, and 0.
4, and 0, right? Okay, so this is why we did it. You know that anytime you do synthetic division, whatever was on top, so in this case it was x cubed minus 8, your answer will be 1 degree less than that. Okay, so since it started out as x cubed on top, this is actually going to start out as an x squared. So it's going to be 1x squared, then the power comes down, 2x, and then 4. Do you see that or not?
I was going backwards. So I did it for,
And then the powers come up?
and then maybe 2x. And then the next step. And then the next one's the next squared.
Either way. Either way. The highest power here, though, is going to be 1 less than the numerator was every single time. So if the numerator had started out as x to the 5th, this would be x to the 4th, then x to the 3rd, then x. But we would have had more numbers.
Okay.
Make sense?
Well, it's stupid, but
Okay.
got it.
All right, so for your homework, I know we only have about 30 seconds left, but for your homework for 5.1, this is for 5.1, do not do what's on the schedule. Do those problems. Uh-huh. And then, you know what, this is the 9th. Anyone have the 10th with them? With them? The book? I'll look at that in a second. When you grab that, yeah, this is the 9th edition, sorry. This is the 9th. Where it has all your homework problems?
Oh.
That thing,
no,
don't, oh, sketch, sorry. For these problems right here, sketch those problems.
Only 65
65 and 67, I believe, are where they give you a picture and ask you to come up with the function. But then the rest of them are just like what we started class with today, where it's already factored and you're just finding like what it looks like, what you did for the take-home part. And the problems 41 through 45 are actually where they give you the information and you have to come up with the function.
So we need to sketch the
Let me see your 10th one.
41 to 45.
Yeah, let me just look at the 10th real quick. For the 10th, it's page 339. It's 43 through 49 odds, and then it's whoa, that's different. 77 through 97 odds. This is for the 10th one. Right, you see the two different things there? Yes?
And the 77 through 79 sketch.
Yeah, those are sketch ones. All right, everybody, have a great weekend.
You basically want us to sketch them all.